Alright, using postulates and diagrams in geometry, this is Scholar Strife doing some math. Here we go. So let's look at some postulates. So remember, postulates are some things in math that we accept without truth. Or without proof, I mean. Without proof. They're true, we accept them without proof. Through any 2 points, there's exactly one line. So if I got 2 points here, there is only one line that you can draw connecting the two. A line consists of 2 points because we need 2 directions. If 2 lines intersect, then they intersect at exactly 1 point. Through any non-3 collinear points, non-collinear, that means they're not they're not on the same line. There exists a plane. There exists exactly 1 plane for these 3 points. And then a plane, so we start out with a plane, contains at least 3 non-collinear points. If 2 points lie in a plane, then the line containing them lies in the plane. So this line is inside this plane. If 2 planes intersect, so we've seen this before, but let's try and do this here. I can't draw it correctly, but basically if 2 planes intersect, think of like 2 pieces of paper. It's a lot harder to draw 3-dimensional shapes here. Basically, 2 planes intersect, they intersect at a line. And if a line is perpendicular to a plane, if and only if the line intersects the plane at a point and the line is perpendicular to every line in the plane that goes through that point. So let's say this is going straight off the page, going straight up. It would be perpendicular to any line going through this point. Alright. Example 1, state the postulate shown in the diagram below. So we have 3 points not on the same line. So through any 3 non-collinear points, there exists 1 plane. So this is basically a matching question. Use the diagram to fill in 2 examples of postulates. Plane Q contains at least 3 non-collinear points. That would be V, Y, and W. The intersection of plane P and plane Q is line B. They intersect along that line. Alright, just sketch a diagram showing RS perpendicular to TV and intersecting at point X. Okay, so we have a line TV, and then we have the segment RS, and it's perpendicular, so it forms a right angle, and it intersects at point X. Alright, so I did this on a different video because I got confused on my notes, but it's good to go over it again. So what can you assume about diagrams? You can assume that all the points are on the same plane. You can assume that angle AHB right here and BHJ right here, those two add up to a straight line. So angle BHJ, AHF, so that is here, is and blank are vertical angles. So remember, vertical angles opposite of our intersection here. So this is BHJ. A, H, J, and D are collinear, so you can assume things are on the same line if there are points on a line. Part E, AD and BF, so that vertical line AD and then BF, that lower line, they intersect at point H. So you can assume things intersect at those points. But you cannot assume that G, F, and E are collinear. You can't necessarily make a line that goes through all of them. Can't assume that. BF and CE intersect. So you can't assume from the diagram, even though it looks like it's going to intersect, and it probably will, but you can't assume it. BHA and so BHA, so we're talking about that one, and CIA, CIA. They're probably talking about CJA. Can't assume if they look congruent. Can't assume that they are. They need the marking that I just drew there in order to be congruent. You can't assume that things are perpendicular, even if they look that way. They need the right angle. And you can't assume things are 90 degrees. Again, you'll need the right angle symbol. And that's all for today. Have a good one.